Welcome back, learners. In our previous session, so we were discussing about the option that what you have in the select one. Now today we are going to discuss in detail about the most important option, what we call it as assign. Right? As the name itself indicate, assign means whatever the material, whatever the property, whatever you have defined first, those things has to be assigned to the corresponding members, right? So in the ETABS, the first procedure is you are supposed to define the materials, sections, properties, whatever is required for your project. All those properties will be defined first. So once it is defined, the next step is you are supposed to draw them, whether it may be beam, it may be column, slab, or footing, or links, whatever may be. So your next step is to just draw them. So once it is drawn, the next step is you are supposed to assign them, right? So what type of material that you are supposed to use for the beam, what type of material you are supposed to use for the column, for the slab, then similarly what should be the dimension of the beam, column, then what should be the thickness, then what should be the load. So everything you are supposed to assign. So in that, let us take the first option in the assign, that is joint. So in the joint, when I go to the joint, in that again you have these many 6 options. So let us see one by one. So in that, the first option is restraint. So if I am choosing restraint, means it indicates what should be the nature of the support that you are giving for your project. Okay, so whether you are giving the simple support, whether you are giving the hinge support, whether you are giving the roller support, whether you are giving the fixed support, what type of support you are giving for the footing of your project. So we are supposed to decide, and we are supposed to assign them. Okay, so now according to that, when I click on that assign, and when I click on that restraint option, you can see in that joint and in that restraint option, so these many options will come. See here, whatever may be the type of support that you are going to consider, totally we will be having the 6 degrees of freedom, right? 3 will be the transitional degrees of freedom, 3 will be the rotational degrees of freedom. So when I say 3 transitional degrees of freedom, so the one will be along this x direction, one will be along this y, and one will be along the z. Similarly, when we have 3 rotational effects, means one will be along this x, one will be along the y, one will be along the z. Now, based on the type of structure, that whether your structure is 2D structure or 3D structure, it will vary. If you are taking 2D, means then you will be having 2 transitions and 1 rotational. And when I say 3D, means you will be having 3 transitionals and 3 rotations. Okay, so now since we are doing 3D structure, definitely we have to look into the 3 transitional and 3 rotations. Now, if your support is a fixed support, okay, if your support is a fixed support, you can see that this is the support what we represent, fixed support. Okay, for example, I'll show you. As I already told, so when I take, we will be having the 6 degrees of freedom. Okay, I can show that this is 1, that is x, then this is 1. Okay, so this is second one, y, and you can see that you can have another one like this, z, right? So x, y, z. Similarly, you will be having the rotation here. Okay, so this will be one rotation, and similarly you will be having so another rotation here like this, and you will be having another rotation here. Okay, Yes, so these are the 3 transitions and 3 rotations. Now, when I say a support as a fixed support, your fixed support will be like this. Okay, I can represent the fixed support like this. Okay, usually this is how your fixed support is, right? So like this, the graphical representation of the fixed support will be like this. So now when I say fixed support, keep it in mind, learners, the fixed support will not have any transitions, will not have any rotations. That means when I am making a support as a fixed support, that support will not make the member to move along this x direction, to move along y direction, to move along z direction. Similarly, to rotate along the x direction, rotate along y direction, and rotate along z direction. That means all the 3 transitions and all the 3 translations and rotations are restrained here. Therefore, when I take fixed support, it will be having 6 support reactions. So one will be along x, that is we call it as fx, one will be along y, we call it as fy, and one will be along z, we call it as fz. Similarly, one rotation will be along x, that is theta x, and another rotation will be along y, theta y, another rotation will be along z, theta z. Therefore, you will be having 6 support reactions because it will be restrained in 6 directions. Okay, so therefore, according to that, now if I want to make the joint as a fixed support, then what you are supposed to do, you are supposed to select all ones. If I select means, it means I am not allowing anything. If I am selecting, this means I am not allowing to rotate, move in the x direction, move in y, move in z, or rotate in x, rotate in y, rotate in z. That means all my 6 rotations, that is 6 movements, has been restrained. So then this becomes the fixed support. Or the shortcut is, if you unselect means, if you want directly the fixed support, you just click on this, automatically your all the restraints will be, your restraints becomes fixed restraints. Okay, yes, this is how. For example, now if I want to show, I'll go to the plan and I'll go to the base. Okay, so what I'll do, I'll select these joints, then I'll just delete them. Okay, I'll just delete, right? So now what I'm supposed to do, so I'm supposed to select the joints which is at the ground level, then go to assign, then go to joint, then you go to the restraint, and since we are making fixed, you select this shortcut option, give apply. Okay, so then if you see, you can see in the 3D structure that your all things, this is how the representation of the fixed support. Okay, this is how the representation of the fixed support will be. You can see here. Okay, this is how, this is the representation of the fixed support. Okay, yes, so this is the representation of the fixed support. Now in case if you want to make the support, this is about fixed one. If you want to make the support as a pinned one, okay, your pinned support or the hinge support will be represented like this. Okay, it will be represented like this. This is the graphical representation. Okay, this is the graphical representation of the pinned or hinge support. Okay, so this is the graphical representation of the pinned or hinge support. So whenever if you make the support as a pinned or hinge support, then here there will be a translational moment allowed in any 2 directions. Usually it will be allowed in x, and the translational moment will be allowed in the x direction and y direction. Okay, and there is no any transitional moment allowed along the z direction, and there will be a rotation allowed in only one direction. That means for this you will be having 3 support reactions. So one will be fx, one will be fy, and one will be theta. Okay, fx, fy, and theta. So the rotation, the translation moment will be allowed in the x direction, it will be allowed in the y direction, and rotation will be usually allowed along the z direction, whereas other reactions and rotations are restrained. Therefore you will be having 3 support reaction for the hinge support or the pinned support. So therefore if you choose this, so this is nothing but your pinned. You can see that yeah, so this is one type of support, right? Yes. So now you can see that if I click on this, your transitional x, y, z, they have been restrained, right? Only the rotations are allowed. That is nothing but your hinge support. Then one more type of support you have, that is roller support. If you choose this one, then I'll show you how it will be represented. Okay, let me go to the plan. Let me select these joints, and if I click on this, if I give apply, you can see that the representation of this will be like this. Okay, you have noticed the difference. This is how it is going to look. So if you want to make, let us connect, let us take these two. Okay, let us take these two joints, this one and this one, just to show. If I want to make it as this one, okay, that means along z it is restrained. Then if you apply, you can see this is how it is looked, right? So if you want to make it as another one, that is the last option, that is this one, you can see it is a simple support. Okay, so it is allowed to move along all the 3 directions, as well as allowed to rotate along all the 3 directions, right? Based on what type of support you want, okay, based on what type of support you want, so we will keep such kind of support. But you know, since we are doing the concrete structure, all the support will be fixed support. Since all the supports are fixed support, so there will not be transitional effect along 3 directions, as well as a rotational effect along 3 directions. Therefore let us keep all our supports as fixed support. Your hinge or roller support will come into picture only when we are doing with respect to the steel structure. Okay, yes. So that is about the first option, that is joint in that restraint. So the next option that you can have is about the springs. I already informed that when we are doing the soil structure interaction, okay, so when we are doing the soil structure interaction, so that times we are going to use this spring option. So if spring options will be of the single spring, or it may be a line spring, or it may be an area spring. So therefore if you click on the spring option, you can see, since we have not defined anything, okay, since we have not defined anything with respect to that of the spring, okay, here we have not defined anything spring properties, either point springs or the line springs or the area springs, as well as soil profile, anything. So here we cannot able to see anything with respect to springs. And with respect to diaphragm, you know, we have already explained what is the significance of the diaphragm. Okay, what is the significance of the diaphragm? Already we have defined the diaphragm. Therefore select your entire structure like this, then go to assign, then go to joint, then just click on diaphragm. Okay, you are supposed to choose D1. You click on apply. You can see that your diaphragm is applied. Okay, that means your each and every joint of your structure will be considered as an individual one, and it will be acted together. Okay, that is about the third option that you have with respect to the joints. One is restraints, that is nothing but your supports. Another one is springs, that is nothing but when you do soil structure interaction. The next one is diaphragm, and next one panel zone. Even you know the panel zone also, okay, we cannot do this because you know we have not defined the panel zone. Since we have not defined the panel zone, we cannot do. Okay, but still let me try to show what it is going to happen. So nothing will be selected. So because no selected objects were found to receive panel zone, we have not defined. So in the same manner you can assign the panel zone also. Okay, so that is panel zone. Then I told you additional mass. This additional mass concept comes only when we are doing with respect to the earthquake resistant design of buildings. So because as per IS 1893-2002, we are supposed to consider the additional mass. So that additional mass, what we are supposed to do, how much you are going to provide, okay, where you are going to provide, everything we have not defined. Again, in the define option you can see the mass source. So if you define mass source here, then that additional mass can be considered here, assign. This additional mass can be considered here. Then similarly, joint floor meshing option, that also we have not done. Okay, so that also we have not done. So so that's why that also we will do when we go to the commercial buildings. Okay, when we go to the commercial buildings we can do that. Okay, here it is not required, right? Yes. So what is this joint assignment, joint floor meshing options means? So together your joints and floors will be considered, that's all. Okay, together your joints and floors will be considered. So how it is going to affect, where it is going to change, everything we will discuss. Okay, everything we will discuss when we go for the dynamic analysis. So that is all about the options that you have with respect to assign. Okay, yes. So the next option that you can expect to have after the joint is with respect to the frames, right? The same properties that what we have used there, right? So in that first, when I come to the frame, you have the first is the section property. So you know, when you click on the section property, you can see all your beams, all your columns can be seen here. Okay, all your beams and all your columns will be seen here, right? So let us do one thing. So let us learn this section property in the next class. I think we may need one or two, three classes to finish your assigns. Then finally we'll go to the analyze. So already we have done the analysis. So then let us go to the design. So we'll continue with the assign option in the next video. Thank you, learners.